today we are going to see one other new concept of AWS. So that is Amazon VPC, which is called Virtual Private Cloud. Okay, so this is one of the important topic in AWS. So you can expect at least 20 to 30% of questions for your Architect exam from VPC. Okay, so what is Virtual Private Cloud? Okay, so we have heard in our colleges or in our colleges like virtual private network. So when you have done some lab so practicals in your college, you would learn what is virtual private network. Okay, so a private network is like a network of computers which are connected to each other or connected to a server. Okay, in a private space. That means that may be a college, that may be an office, okay, that may be a data center or something. So all these systems or all these servers are connected privately. So that means it is not connected over internet. Okay, they can be communicated within the network, but they cannot be connected or communicated through internet. So that type of network is called a private network. Okay, so when coming to the cloud AWS, so as it is a cloud, okay, it is called virtual private cloud because all our servers are being okay running in the cloud. So all the servers which are running in AWS cloud, when they are connected privately, okay, so when they are like being in a private network or within the private space, so then it is called as virtual private cloud. Okay, so in this part, like we mostly have some theory part, so you need to like keenly learn all the basic concepts of networking here. Okay, so AWS is like something like all which is interconnected to so each other services like okay, basically it is a network. So you need to learn few networking concepts and virtual VPC concepts first to understand. So and to how to create a VPC and how to create subnets in that and how you create servers in that and how you may communicate them, how you make create a public and private subnet and all. Okay, so we'll go one by one and learn like what we'll do or like what we'll try to create a network, and to create that network we need to learn some concepts. So learning one by one, and we'll go creating one by one, and we'll create by the end of this VPC session we'll create a virtual private cloud and all the components inside the VPC. Okay, so first thing you need to learn, okay, is understanding CIDR blocks. So that is understanding the IPs and IP ranges. Okay, so CIDR stands for classless interdomain routing. So this is a method for allocating IP addresses. Okay, so this is in short called as CIDR. So and these are called CIDR blocks. So whenever we say CIDR, it is something like classless interdomain routing. Okay, so these are previously like we have seen them in our security group rules and in AWS networking in general. Mostly these are used in security groups and AWS networking. So while learning about the EC2 security groups, so we have seen this, okay, in particular IPs. So we need to we used to allow some ports, okay, so for this particular IPs and all. So here like we are using the same CIDS in the AWS networking also. So don't worry about this, like we'll learn about this CIDR deeply today. Okay, so they help to define the IP address range. So whenever you are working in a network, so there will be so many servers connected, okay, connected in that network. So for each server you need to define an IP address. Okay, so to pool some IP addresses, so for all these servers you need to pool some IP addresses, okay, from 1 to some different range. Okay, so this range can be defined by this CIDR blocks or CIDR range. Okay, So when we talk about CIDR, so this will be the format of that. So we have seen, so there will be www.xxyyyzz/32. So this might be an IP address whenever we get a /32. Okay, so this WXYZ, so there are 4 digits which are separated with the point, right? So each one is called an octet. So we have 4 octets combinedly is called an IP address, and slash this range, CIDR range. Okay, so whenever we give an IP address /32, so that means it it indicates that it allows only one IP. So the IP range is only one IP address. And whenever we see, so here if you see this 122, 149, 196 and 85/32. So then this is like only this IP address, okay, is allowed to access the SSH port. Okay, so /32 indicates a single IP. Similarly, so 0.0.0.0./0. So this indicates all IPs. So that means here, so here the HTTP port is allowed from all the IPs. Okay, so but when you define like this, so it leaves 192.168.0.0/26. Okay, this means /26 means like it is allowing the IPs from 0.0 to 0.63. Okay, that means you are getting 64 IPs. So from 0 to 63 you are getting the 64 IP range. The range is from 0 to 63. So this is how we define the range. So based on the the CIDR block, we'll get the IP range. So we'll see how we'll get this now. So here if you see, so we'll understand how the CDR works. A CDR consists of 2 components. One is the base IP and the subnet mask. Okay, so the base IP is something which represents the IP address. That means the 4 octets. Okay, so example is like 10.0.0.0 or 192.168.0.0. So all this is called a base IP. Okay, these 4 digits which are divided by the point is called a dot is called a base IP. So when coming to the subnet masks, so this defines how many bits can change in the IP address. Okay, that means like how many IP address ranges, like how many octets can be changed in the IP address. For example, the subnet mask is something like /0 /24 /32 something. Okay, so this can take 2 forms. So one is like if you see here, so if you give an IP address /8, so that means so that 255 is fixed, and you can this 0.0.0. These 3 zeros can be changed with numbers. So that means you will get 256 into 256 into 256. So this many IP range. So if you give /16, then this 255 and 255 is fixed, and you can change only, so not only 255, the first 2 octets will be fixed, and you can be able to change the last 2 octets. So you can do it from 0 to 255, and here also you can put from 0 to 255. So that means you will get a range of 255 into 255 IPs. So if you give /24, you can change only the last octet. Okay, so you can put the last octet from 0 to 255. That means you will get a IP range of 256. So if you give /32, as we've seen in the previous slide, if you give a /32, it defines that it's only one IP. So you cannot get a range if you give 32, it's fixed one IP. Okay, so how this and how the range will come, we'll see here. So understanding the CDR subnet mask, how the CDR subnet mask works. Okay, so the subnet mask basically allows the part of underlying IP to get additional next values from the base IP. So if you see here, this is one example. So as we said, if you go with 192.168.0.0/32, that means it allows only one IP. Okay, so see in the second slide, if you see, so 192.168/31. So 31 means, so simple calculations you can do is, so this number, if you take this number and minus with 32, so you'll get a value, right? 1. So if you take it as 2 power 1, okay? So then it is 2 power 1 is 2. That means it allows two IPs. The range is from 00 to 01. Okay. The slash 31 will allows only IP range of two IPs. That is from 0 to 1. Similarly, if you go to 30 slash 30, that means it's 2 power 2. 2 power 2 is 4. That means this allows the IP range of 4 IPs. So that is from 0.0.0.0 to 0.3. Okay. Similarly, if you go slash 29, so that means 32 minus 29 is 3. So 2 power 3 is 8. Okay. So that means it allows 8 IPs, 00 to 08. So similarly, it increases the, okay, so IP address range. If you decrease this, okay, CIDR number or subnet mask number. Okay. So similarly, when you come here, so if you go to slash 16, that means 2 power 16 is 65,536. So that means if you give slash 16, you will get an IP range of from 0.0.0 to 0.0 to 255 into 255. So if you give a subnet mask or if you give a CDR block like slash 16, you will get an IP addresses range of 65,536 IP addresses. Okay, in this, like mostly in this session, we'll mostly use this 240, 24 or 16 because this IP range is enough for us. So if you give this, see, slash 24 means 2 power 8, that is, it provides 256 IP addresses. That is like 0.0 to 0.255. Okay, so and we also said like if you give slash 0, then it indicates the IP range of all IP addresses. That means you'll get IP addresses from 0.0.0.0 to 255.255.255.255. So all these IP ranges will be available in this CIDR block. Okay, so here we said like the IP address is divided into 4 octets. So first, second, and third, and fourth octet. So when if you give slash 32, so we cannot change any octet. Okay, when you give slash 24, we can change the fourth octet. The last octet can be changed, and the 3 octets are fixed. So that is like if you go here, okay, slash 24. So here it allows 256 IP addresses. That means, so 192.168.0. 0 is fixed. So these 3 elements will be, 3 octets will be fixed. Only this octet you can change from 0 to 255. So here see 0 to 255. 192.168.0 is fixed. Okay. So slash 24 means only the last octet can be changed. So if you give slash 16, then last 2 octets can be changed. So this is the one. So here we have 0.0 to 255.255. So we can change the last 2 octets if you give slash 16. So similarly, if you give slash 8, the last 3 octets can be changed. Okay, and if you give 0, all octets can be changed from 0 to 255, and we'll get a IP range based on these combinations. Okay, so this is something you need to understand very clearly. You will expect like 1 or 2 questions from this also. Okay, so we'll go to the next slide. So we'll understand a little bit more about the CIDR with some small exercise. If you give 192.168.0.24, so the IP range will be from, so it is slash 24, right? That means only the last octet can be changed. So then the IP range will be from 0.0 to, okay, 0.255. Only 256 IPs can be, we can achieve only the range of 256 IPs. If you use slash 16, then we'll get 65,536 IPs. That means like we can change from 0.0 to 255.255. So if you give something like slash 32, so there is no range. So it allows only this single IP. And if you give 0.0.0.0 slash 0, then it allows all IP. The range is from 0.0.0.0 to 255.255.255.255. So all IPs will be available in this range. So we have one link here. So I'll open this and I'll show you, like, this is one website which is used to identify the IP address range, IP addresses guide. Okay, I'll share this. So if you can see this, so here we have two things. So if you enter an IP address range, uh, so here we have CIDR to IPv4 address. So click on this and here we have two options. So if you enter the CIDR and if you convert it, so it will give you the IP address range. So what is the first IP and what is the last IP? So and how many total IPs will be in that particular range. Okay. So if you give here like 10 dot, so if you give like slash 27, 0/27. So if you calculate this, so see, so the first IP is 0.0 and the last IP is 0.31. That means you will get a pool of 32 IP ranges. Okay. So if you want to get the CIDR block with the range, then you can use this. So I want the IP address range from, so 255. So I want the range from 0.0 to 255. So if you calculate this, so it will provide you the CIDR address. Okay, it will provide the CIDR range, CIDR range. So this is one of the, like, you can use this to get the different types of combinations of the CIDR blocks and what's the CIDR block if you want to give a particular range here. So you can check the CIDR with particular range of IPs. Okay, so try to go through this website and check. Okay, so coming back to our presentation, so this is CIDR blocks. So hope you understand about these CIDR blocks. Okay, so this is one of the important things. So to create a VPC or to build a VPC. Okay, so now we'll understand what is a private public versus private IP. So we have, when we create some EC2 instances, okay, in our EC2 session. So then what happened? Then we have seen, so a public IP address and a private IP address for each instance. So what is this public and private IP addresses? So we'll see this. So the Internet Assigned Numbers Authority, so that is called IANA, establish certain blocks of IP address for the users of private and public internet addresses. Okay, so this IANA is an, so as an authority like which establish some block of IPs. So they have fixed some like rules or some ranges for where the public and the private IPs need to be used. So private IPs ranges can be used only in this below values. So one is either the private IPs can be categorized or used between these three only. So either from 10.0.0.0 to 10.255.255. So this is a big network. This is used in a big network. So whenever you have a large network, so then you will use this range. Okay. So this is 172.16.0.0. So this IP range. So this is by default AWS default VPC in that range. So AWS, when you create a console, so it comes with a default VPC. Okay, so that is the VPC like which we have used till now to create the all instances and all. Okay, so this AWS default VPC comes with the range of IPs starts from 172.16.0.0 to 172.31.255.255. Okay, so this CIDR is something like 172.16.0.0/12. Okay, so this CIDR will give the range of this IP addresses. So AWS by default VPC will be using this. Okay, And 192.168.0.0, I think we have learned, we have like heard of all these IPs in our real life. So these are mostly used in the home networks and all for our routers, and in some small networks. Okay, we'll be using this 192.168. Okay, so all the rest of the IP addresses. So apart from these IP addresses, all other IP addresses are public IP addresses in the internet. Okay. So one thing you need to understand is public IP is something which we connect through internet, and private IP is something which we use to communicate within the network. That may be a VPN or VPC. So as we are learning about AWS cloud here, so we are going with VPC. Okay, so understand that these IPs are used in VPC, and all other IP addresses are used over internet. Okay. So default VPC. So we'll see what is the default VPC that we get with the EC2, or we'll get with the AWS while we create AWS console. So what this default VPC gets, all the new AWS accounts have a default VPC. So new EC2 instance, okay, are launched into the default VPC if no subnet is specified. So whenever you won't specify any VPC or the subnets while creating EC2 instance, they will be okay launched in the default VPC which is provided by the AWS. So default VPC have an internet connectivity, and all EC2 instance inside it have a public IP4 address. So the instances which are created in the VPC, default VPC, have internet access by default. Okay. So we also get a public and a private IPv4 DNS name while creating EC2 instances. Okay. So this default VPC will go through one by one, and we'll see what are the features that we have got in default VPC while we got an AWS console. So we'll go to the console again. So we'll go with the root username. Okay. So this is our AWS console. So we'll go to here. If you search VPC, so we'll get a VPC here. So we'll open this VPC and see what the default VPC we got. So here by default the AWS has given us a VPC because like it is difficult for the newcomers or the beginners to create the VPC and subnets and all to start with their EC2 instances. Okay, so that's the reason like AWS has default by default given a setup of VPC so that all the other EC2 instances or other EC2 services can be run in this VPC by default. So if they want to create a new VPC, they can create, or else if they don't know how to create a VPC or they don't want to get into all this and configure all this, they can just use the default VPCs. Okay, so here these are all the options which are being okay used in the VPC. By the end of the class, will be getting flowing of all these options. So first we'll go to this VPCs. So here we can see like we have one default VPC. So when you click on this, okay, so if you go with this, okay, so here we have the VPC details. Okay, so and here if you can see the CIDR block for this VPC is 172.31.00/16. So if you copy this and if you can paste it here and if you can calculate, so if you can see right, so the IP range is from 172.31.00 to 172.31.256 to 256. So we are getting an IPs of total 65,536 IPs. Okay, so the IP range is 65,000 plus. Okay, so that means in this VPC you can create different subnets and different servers of 65,000. Okay, so and here if you go uh, so we have something called the route tables and network ACLs. So we'll see about these route tables and network ACLs in the coming classes. So every VPC will be connected to a routing table. So here, like, we can assign some route tables here. We have them CDIRs. So these are the CDIRs. So we can assign, or so we can edit our CIDRs. We can add like multiple CIDR blocks to our VPC. Okay, so we can add up to 5 CIDR blocks to the VPC. Okay, so if you go here, your VPCs, and we have something called CIDRs and flow logs and tags. So all of empty. So we'll see. So how the resource works, and every VPC is connected to an internet gateway and a route table. Okay, so we'll see all this. So just we'll see about what's a small overview here. And this VPC is connected to, and here we have something called subnets. Okay, so these are the 3 different subnets which are created in 3 different availability zones. So subnets are the part inside the VPCs. And so inside the VPC, we can create a subnetworks which are called subnets. Okay, we'll see what these subnets and why they are used. Okay, by default, like, we will get 3 subnets and we'll get 3 availability zones to support this. Okay, multiple AZ. And here, if you see, each subnet have a default CIDR range. Okay, so here we have 16/20, 00/20, 32/20. So that means it will get a IP range of 4091. So if you can copy this, so I want to show you one thing. So here we have one subnet. Okay, this is in the availability zone C. Okay, so it is having an IP address CIDR range of, so 172.31.16.0.20. So, and it is saying it has 4091 available IP addresses. Okay, so if you go to this CIDR, and if you check this, so here if you see, it is saying it has 4096 IP addresses of total. But if you see here, so it is showing only 4091. So we are going to see about this in our coming classes. So here if you go with each subnet, so each subnet, like, it has a digital subnet ID and it have like range of IPs. Okay, it has also an ARN. It is connected to a VPC. A subnet is connected to a VPC, and a subnet is also connected to a routing table. Okay, so it has a CIDR range. Okay, and it has a flow logs and routing tables. So here we'll see what are the routing tables, and these routing tables, see here, it is connected to a thing here. So when you click on this, this is called an internet gateway. Okay, this each subnet is connected to a internet gateway. So this is the internet gateway which is providing internet access to our EC2 instances which are created inside your default VPC. So when we create an EC2 instance and we are trying to download something, or when we try to install something, it is connecting to internet. Okay, so that internet is provided by this internet gateways. So when you create a default VPC, by default we won't get any internet access to that, okay, VPC or subnet. So we need to add an internet gateway to that VPC to get an internet. So we'll have a default, we'll get a default session for this. We'll go one by one. So this is something like a high level intro for all the options in the VPC. So again, if I go to subnet and if I select any subnet, so I'll get network ACLs. We'll see what is this network ACL. So these are something like the traffic, allowing or denying the traffic to the network. And the shared reservation, sharings and tags is nothing here. So we'll see one by one here. So we have a routing tables. So we have one routing table, and here we can define the routes. So what are the routes and what are the routes that need to be connected to the internet? Okay, so what are the subnets associated? So here if you see, so there are no subnets implicitly connected. Like here we have some subnets which are associated explicitly. So we have 3 subnets which are connected to this routing table. Okay, so in each subnet we have, and this routing table is connected to internet gateway, and through this internet gateway and this routing, we are getting the internet to this subnets and all the EC2 instances, which are all the RDS databases which are connected inside this subnets. So we are able to get internet to it. So one thing you need to keep in mind is, so in AWS we can create a private and a public, okay, subnets, and we can create an EC2 instances in that. So private means something which you will be communicated to the servers within AWS, okay, AWS VPC, and public EC2 instances or public subnet is something which is connected to internet, and that can be, okay, interacted or connected through internet. So we might have some scenarios like where we don't need to connect to our servers through internet, so they will be running internally, and we can be connected to those instances using some load balancers or some other applications. So if you say, if you want to run an application, and if you want to connect that application to the database, so you don't need to allow the database to, okay, run in a public subnet. Okay, you can keep that private, and you can keep the EC2 instance in a public sub, okay, in a public subnet, and you can connect the database from your public EC2 instance to private, okay, EC2 instance, database instance. Okay, so don't worry, like we'll go one by one, so don't get confused. So this is something like a high level uh, intro. So we'll go one by one, and we'll understand that what are this one by one, and we'll try to create our own VPC. Okay, so one thing you need to understand is VPC is a like network, and inside that network, so we'll have some subnets, and inside the subnet we have our EC2 instances and EC2 services. Okay, so to get the internet access to the VPC, we need to connect an internet gateway to the VPC. Okay, so and routing tables to the VPC, which allows the internet access to our, okay, VPC. So if you go to this routing table, I want to show you one thing. So here, as I said, here we will define the routes. So here we have the routes, and based on this CDR, if you can remember about the EC2 instances security groups. So there what we are doing is, we are giving a pool of IPs, and we are giving a port, okay, and we are allowing this port to a pool of IPs. Similarly, in the routing tables also, we'll give a pool of IPs, and we'll say like it should be connected to internet, or this pool of IPs need to communicate locally. Okay, so that is something we do with this routing tables. Okay, so this is like something about this default VPC, which is by default created by the AWS when you create an AWS console. So here this is the default VPC. Okay, so coming back to our slides. So that is something like a default VPC. So walkthrough. So now we'll see what is VPC in AWS. Okay, so what is VPC in AWS? One second. Okay, so VPC stands for Virtual Private Cloud. So, and you can have multiple VPCs in AWS region. So we can create 5 per region. So when you want to create a multiple VPCs, you can create maximum of 5 VPCs per each region. Okay, so this soft limit is something which is like by default limit that is defined by the AWS console for each user. So if you want to increase it, you can put a request to AWS, and they can increase this limit. Okay, so the max CIDR per VPC is 5. Okay, as I said, so we can assign 5 CIDR blocks for each VPCs. The minimum size is /28. That is like at least 6 IP addresses need to be, okay, allocated for a VPC, and the maximum size is /16. That is 65,536 IP addresses can be assigned to a VPC. Okay, so because VPC is private, only private IPv4 address ranges are allowed. Okay, as we already discussed about this. So as this VPC is a virtual private cloud. So we can only assign the IP addresses range among these three. Okay. And other thing is your VPC CIDR should not overlap with your other networks. So say like we have a internal VPN or VPN in our particular like office or companies. Okay, so there we have some IP addresses. So there might be some chance of our like connecting from our local VPN to AWS VPC. So at that time, if you use the same IP addresses in the network, in the local network and the virtual cloud, there might be some issues. So if you have this local network and this, if you have a use case of connecting your local VPN to our VPC, so then it is better to like take care of not overlapping these IP addresses from your existing local network and AWS VPC. Okay. So now what we'll do is like we'll take a region. So in a region, we'll create a basic VPC. Okay. So we'll see how to create a basic VPC. We'll go here. So this is our VPC page. So you click on VPCs and here you can see create VPC. Okay. So VPC only. Okay, we are creating VPC only. So here I am giving a VPC as my demo VPC. So this is a IPv6 block. So I am giving an IP address range of 10.0.0.0/16. So that will give us almost like 65,000 IPs. So for now we are not using IPv6. Okay. So by tenancy here, if you see this tenancy, so if you select this dedicated, so what happens is, as we said, VPC is a like pool of servers that will create in the cloud. So when you select this dedicated, okay, tenancy, what happens is, we know like AWS is have a shared hardware, right? So AWS has a hardware and we are creating those uh, in EC2 instances or all or VPC inside the hardware. So if you use this default option, then it will be creating the EC2 instances in a different hardwares in their data center. So if you use this dedicated, so then what happens is it uses a dedicated hardware only for your VPC. Okay, that means like all the EC2 instances, all the load balancers, all the RDS databases which you create in this VPC, those will be dedicatedly stored in a fixed hardware or a single hardware. Okay, so that like the communication between those EC2 instances and all will be more fast when compared to distributed or various hardwares. Okay, so but when you create when you opt for this dedicated, it will cost you more because like they are dedicating a particular hardware for you. So so that like we'll go with the default thing. So but understand like if you select the dedicated one, so all your uh, elements or all your services or all your servers or load balancers which are created inside this VPC will be okay. It's created in a dedicated hardware. Okay. So I'm selecting this default thing, and here we have given a tag, and that's it. So we can create a VPC here. So now we got. So this is my VPC. So this is the CIDR range for my VPC, and here so we have a DHCP output. So here we here give this is not a default VPC. Okay. So when you click on this, if you can see here, so we'll get the CIDR range of this one. Okay. And that's it. Like we don't have any other options. So here we have a resource map. So by default there is empty. There's nothing here. So that means now we have created a so in Mumbai region. So in our Mumbai region we have created one VPC. Okay. So coming back to our slides. So now we have a region, and inside the region we have a VPC. Okay. So coming to the next thing. So now we'll see what are subnets. Okay. So AWS reserves 5 IP addresses, the first four and the last one in each subnet. So as we said, like each subnet is something which is created inside a inside a VPC. Okay, inside VPC we can create some subnets. Okay, for each subnet we have seen they have a dedicated CIDR blocks. Okay, so for each subnet, if you can see there in the previous, okay, so I have shown you here. So if you go to the subnets here, and if you see this, if you click on the subnets, so this is one subnet, and each subnet have a CIDR block, and here we have a IP. So in the previous, like before, I have said this IP range will allow 4096 IPs, but there is only 4091 IPs available when you create a subnet. So this is because here, so AWS resource 5 IP addresses, the first four and the last one in each subnet. So that's why we have only 4091 IPs to use in our subnet. So these 5 IP addresses are not available for use and can't be assigned to any EC2 instance in our subnet. Okay. So what are these 5 IP addresses is? So first 5 IP addresses, what is like, first thing is 0.0. This is used for the network address, and .1, this is reserved by AWS for the VPC router. Okay, so we have seen something like a route table and all. So for this, the AWS has reserved this .1 IP. So .2 is reserved by AWS for mapping the AWS provided DNS. So AWS is giving us a DNS when we create an EC2 instance. So to map the EC2 instance to a DNS, so this IP address is used by the AWS. And .3, this is reserved by AWS for future use. Now, like if they have any other feature that they need to link to the subnet, then they will use this. So by now they have just reserved it and kept it aside, and it is not being used by the AWS also. And the last IP is this one, which is used for the network broadcasting address. So as AWS does not support broadcast in a VPC, therefore this address is reserved to the reserved by the AWS. So one exam tip. So here is, if you need 29 IPs. So say like in your subnet, if you want 29 IPs, so then you need to, if you choose /27, okay, you can't choose /27, because if you choose /27, that means it will give you IP addresses range of 32 IPs. Okay, in this 32 IPs, if AWS removes 5 IPs, so then you will get only 27 IPs. So that is, which is less than 29. So if you want to choose any IP address pool, if you want to get 29 addresses, then you will go to /26, which give you 64 IPs. Okay, so you need to be keen on this, because like based on the range, so when you want to create a subnet, so you need to get a range, and you need to subtract 5 from that, so that you will get the actual range of IP addresses that can be used inside your subnet. Okay, so this is about subnets. So what we'll do is we'll go and create a public and a private subnet in a single availability zone. So we have already created a VPC, so we'll create a subnet. So we'll create 2 subnets, one is private and other is public, in a single availability zone. Okay, so again we'll go to our VPC AWS console. So here, like we have the default and the our custom, like our VPC, and here we have subnet which we are getting from the default VPC. So if you don't want to see all this, what you can do is, here you can select a VPC here. So this is my demo VPC. When you click on this, so only the elements of all the options of the subnets of the route tables which are related to this particular VPC only will be visible here in the console. Okay, so here we'll go to the subnet. We'll create a new subnet here. So we need to select a VPC where we need to create the subnet. So I'll select this, my demo VPC, and here we can create subnet here. So for the first subnet, I'll give the name like public subnet A, and the availability zone will be in AP South 1. Okay, so as I'm creating in AP South 1 A, 1A, I'm giving it as a public subnet A. Okay, and the IP range will be from 10 dot, I'll give like 0.0.0 slash 24. Okay, so that means I can get a range of 256 IP addresses. Okay, so because as this is a public subnet, so 256 IP addresses is enough for us. So because like we won't create more than 250 or 200 EC2 instances, right? So this slash 24 will be enough. So we have given a name, public subnet. We are creating the subnet in a one availability zone, 1A, and we'll add an other. So now I'll add 4 subnets. So but we are using only 2, but like I'll add 4 subnets here. I'll add another public subnet B. So this I'll create in my AP South 1B, and for this I'll give a range of 10.0.1.0 slash 24. Okay, so if you can see, this IP address will come from range of 10.0.0 to 256, and this will get. So if you can go this and copy it, and if you go IP address guide, and if you paste the CDR here, so it will get the IP range from 00 to 0255 to. So if you take this one, so here after 255 it will start from 1.02. So here if you check the range, so it will come from 1.0 to 1.255. Again I'll get 256 IPs. Okay, so here I'm creating 2 public subnets, one in AP South 1A availability zone and 1B availability zone, another subnet. So again I'll create 2 private subnets. So private subnet A, which I'll create in my 1A region. So and this range I'll give from 10.0.16.0 slash 20. So this will give us more range. If you can see, copy this, and if you see here what is the range of IP addresses, so if you can calculate here, so it will give us from 16.0 to 31.255. So we'll get around like 4096 IPs. Okay, similarly I'll create another private subnet, private subnet B, so which I'll be creating an AP South B, and I'll give the range of 10.0 dot, so 32.0 slash 20. So I'm giving a range, CIDR range like this. Okay, so now we have 2 public subnets in 1A and 1B, and we have 2 private subnets in 1A and 1B. Okay, so let's go and create these subnets. Okay, so now we have 4 subnets here. Okay, so here we will get, for the private subnets we have the 251 IPs available for the public, and for the private we have 4091 IP addresses which are available to use. Okay, so here these are the 4 subnets. Okay, so now we have created a VPC, and inside a VPC we have created 4 subnets here. Okay, so now what we'll do is we'll see what is an internet gateway. Okay, so internet gateway is it which allows resources like EC2 instances and DB RDS databases in a VPC to connect to internet. As I said, it is not mandatory for all the EC2 instances in AWS VPC to connect to internet. So there are some private instances and some public instances. So for the private instances, for the public instances, if you want to connect to internet, so those internet will be provided by this internet gateway to the EC2 instances through VPC. Okay, so it scales horizontally and is highly available and redundant. So horizontal means like we have seen what is horizontal scaling and vertical scaling. So horizontal scaling means it is to increase the speed. Okay, and it can scale based on the high availability and redundancy. So this must be created separately from a VPC. So we need to create a separate internet gateway, and we need to one VPC can only be attached to one internet gateway and vice versa. And one internet gateway can be attached only to one VPC. Okay, so internet gateways on their own do not allow internet access. Okay, so when you create an internet access, by default they won't, and when you create and assign this internet gateway to a VPC, by default they won't give any internet access to our EC2 instance. There we need to create some route tables and they must be edited. So route tables must be created and also be edited to get this net access to our VPC. So now what we'll do is, so we'll add an internet gateway to our VPC. So here we have a region and we have already created a VPC here, and we in a availability zone in a 1A, say like in AP South 1A, we have one public subnet and one private subnet. And now we'll add an internet gateway to our VPC. So to do that, so we'll go to our AWS console again. So we'll go to internet gateways, and here see like there is no internet gateway in this particular VPC as of now. So we'll create an internet gateway and we'll give my demo VPC internet gateway. Okay, so this is the name, just it's simple, just give the name and create an internet gateway. So now we have created an internet gateway, and you can see the state the state is detached. So we'll go and attach it to a VPC. So we'll click on attach VPC and we'll select my demo VPC and we'll attach the internet gateway to that VPC. Okay, see now our VPC is connected to an internet gateway. So if we'll go